welcome to How to Succeed at Cost Optimization on AWS. My name is Rowan Omar. I'm a lead technical account manager based in Sydney. Cost reduction is one of the advantages of moving to AWS. If we look at how organizations move to the cloud, most of their conversations start with cost, as AWS allow customers to trade capital expense for variable expense and only pay for IT as they consume it. So let's have a look at our agenda. First, we're going to define what this cost optimization means and explore some of the common mistakes customers fall into when they make optimization decisions. We'll follow that with guidance on how you can succeed in your cost optimization journey using cost optimization design principles and tools. Then we'll finish with takeaways to get you started. So what is cost optimization? If we look at the well-architected framework, it defines cost optimization as a mechanism to deliver business outcomes at the lowest possible price. What is really important here, it's not just about the price. We've got business outcomes, so it's critical that we understand what are we delivering and not just looking at the bill. And that takes us to the first common mistake. Customers are not measuring their business outcomes, and they are typically building more and more workloads without optimization. So why business outcomes matter? Think about why you actually came to the cloud. Typically, it's around innovation, elasticity, and agility. Customers want to spin up resources when they need them, deploy hundreds or thousands of servers in minutes. And they want to focus on developing applications, features that differentiate their business and transform their consumer experience. With this speed comes trade-off and a bit of waste. They may potentially focus more on delivering new features versus going back to clean up some of the things they used through testing and development cycle. The key here is that we want to focus on wanting to stop waste from being built, not removing it after it's already there. The second common mistake is some customers get caught in the waste cycle. Sometimes design decisions are not directed by data. Instead, temptation always exists to overcompensate rather than spend time to benchmark for the most cost-optimized deployment. And that usually leads to over-provision and under-optimized workloads. As an example, if you look at the way most customers operate, they create workload that is over-provisioned and has some waste. They obviously pay for that waste. Then at some point, they decide to do something about it, whether by performing discovery or analysis. Then they pay again to remove that waste. From this cycle, we can see once customers create waste, they pay for it for a substantial amount of time. And when the workload matures, they go back and try to optimize. This process repeats itself over and over again. The other thing is there are always going to be more builders in the organization than the number of people who are optimizing, and that is expected. Looking at the diagram, while you might start to optimize a project, another project kicks in and another workload gets started. You start to fall behind. Before you finish the first cycle, you start looking at the second cycle in a continuous spiral. If you are playing a catch-up game, you won't be able to trim and remove waste faster than your teams create and build workloads. So the key here is we want to design for cost before we start building. This removes all the rework, cost of analysis, and cost of remediation. And that brings us to the third common mistake. Customers sometimes don't factor in the efforts and the risk when they do optimization work. You gotta look into what is the business outcomes when you perform optimization work from a business cost perspective, not just technical cost. Some customers, when they do optimization work, tend to focus on how much they reduce the bill down by. However, they're not actively focusing on what did it cost them to make these changes. If we need to refactor a workload to perform optimization, there will be testing, there will be validation. All of that comes at a cost that need to be factored in. Additionally, the time spent by the engineers or developers to perform these changes is an overall cost to the business. Another thing we need to think about is the risk of implementing the changes to an existing workload when we try to do optimization work. It's always better to design for cost from the beginning, so we don't need to refactor workloads, pay for additional cost of mitigation, and instead we build efficiently from the start. Now let's talk about what are the main ingredients to help us succeed in cost optimization. The first formula for success is behavior change. Cost optimization is fundamentally a behavior problem. The reason you need to optimize is that people are not following best practices. You need to find a way to help them do the right thing, and that is a behavior change. We got to ask ourselves, how can we make the engineers who create this workload care about the cost of the system? So we need to change our behavior around cost optimization and treat it similar to the way we treat security or operations, by establishing and following through on a framework to help us succeed. So let's go through what that looks like. First, we gotta identify someone or a team that will ultimately be responsible for managing AWS costs. Having an owner who will lead planning, execution, and reporting outcomes of cloud financial management activities. Second, we need to establish a partnership and regular cadence between finance and technology stakeholders. This will allow finance stakeholders to become more cloud savvy by understanding different pricing model and payment options, and the technology stakeholders to become more finance savvy by participating in cloud budgeting, cost and usage reporting. This partnership is a key for success. Third is to charge back cloud costs to the line of business responsible for deploying and using the cloud. You can allocate cost of the accounts using AWS organization, or the cost of resources using cost allocation tags to drive cost awareness and accountability within your teams. Fourth, establishing visibility and baseline cloud spend and unit cost, then track them over time to determine the efficiency gains from your actions. You also need to provide your internal stakeholders with access to AWS Cost Explorer, so they're able to track what are they building and how much that translates to. Fifth is leveraging services, features, and tools available to you from AWS, like AWS Budget and AWS Cost Anomaly Detection, to improve cost predictability and detect anomaly to limit billing surprises. And lastly, leverage different price options like saving plans or reserved instant next to EC2 right-sizing recommendation from AWS Cost Explorer to start reducing the cost associated with steady workload and idle underutilized resources. In addition to AWS native tooling options, AWS also have an extensive partner network available through our Amazon Partner Network, who provide managed service that offer an extended set of customer support on visibility, tracing, and chargeback. To learn more about partner solutions, please visit our Cloud Management Tool Partner Competency website. The second formula to succeed at cost optimization is to build efficiently from the start and design for cost. To focus on efficiency, we need to stop talking about the dollar. The dollar sign is not efficiency. We need to look at the outcomes for the dollar. How many business outcomes are we delivering for each and every dollar we spend? Efficiency equals output divided by cost. If you can increase your output for the cost or decrease your cost for the same output, then you're going to be more efficient. For example, if you have 2 web servers costing you around $10 per month to serve your website for an average of 50 users, then you needed to scale up to 6 servers costing around $30 per month to cater for a peak period, maybe a Christmas sale or any marketing campaign, which got you around 200 users on your web page. The conversation shouldn't be about the $20 increase in EC2 usage. It should be about that you served over 4 times more your average monthly consumers, and for that you spent $20 extra this month. So every time there's a conversation around cost, we need to turn it around to a conversation about efficiency, which is what output got delivered divided by the cost. There is a well-architected lab on how to measure workload efficiency that I would highly recommend you to have a look at. Now let's talk about how can we build efficiently based on best practices and design principles. First of all, it's AWS well-architected framework, which describes the key design principles and architecture best practices for designing and running workload in the cloud. By answering a set of foundational questions, we will learn how well our architecture aligns to cloud best practices and get the guidance to make improvement over time. The cost optimization pillar, part of the well-architected framework, provide guidance on avoiding unnecessarily cost by focusing on key topics, include understanding where the money is being spent, selecting the most appropriate resources and its type and size, analyzing spend over time and tracking it, then scale to meet business needs without overspending. That will put you on the right track from the beginning, managing cost of the workload and minimize waste, which will free up your time to do more agility and innovation. It will also help you understand what is the current workload position is. Then you can plan with your teams how you want to improve and where to start. Another thing is to improve and build your organization capability using well-architected labs. If you haven't seen it before, it provides practical hands-on guidance on how to implement cost optimization on AWS. It can also build your capabilities around the platform. They are typically short, around 20 minutes long, so you can easily fit them within your schedule. All labs are aligned to the well-architected white paper and the well-architected tool. So if you are doing a review or reading the well-architected white paper and want to know how to implement best practices, you are able to find the right lab quickly. One lab I would highly recommend is the Cost Optimization Journey, which is recently published in the well-architected labs under Cost Pillar, and it can help you plan yours. So by anchoring on resources like the well-architected framework and well-architected labs, it will help you understand exactly where are you at, where you need to focus, and what you need to start with. It will also help you improve and build your organization capabilities. So based on well-architected cost optimization pillar, here is an overview of cost optimization design principles and its best practices. The first principle is to implement cloud financial management. You need to invest in cloud financial management. Your organization needs to dedicate time and resources to build capability in usage management and this new technology domain to become more cost-efficient organization. The second is to adopt a consumption model. Pay only for compute resources that you require, and increase or decrease usage depend on the business requirements. For example, development or test workloads are typically used for about 8 hours a day during the working week. By stopping these resources when they are not in use, you could achieve a potential cost savings of 75%. That is a usage of 40 hours versus 168 hours. The third principle is to measure overall efficiency. You got to measure the business output of the workload and the cost associated with delivering that workload. The fourth is to stop spending money on undifferentiated heavy lifting. AWS does the heavy lifting of data center operations like racking, stacking, powering, and cooling. It also removes operational burden of managing operating systems and application with managed services that allow you to focus on your customers and your business project rather than on IT infrastructure. The fifth and final principle is to analyze expense over time. It's easier on the cloud to identify the usage and cost of systems, which then allow you to charge back the cost of these workloads to individual workload owners or teams. This helps measure return on investment and give the workload owners the opportunity to go and optimize the resources and reduces costs. Another thing to check is the recent AWS announcements on the cost management. As AWS continuously release new services, tools that could help you reduce your overall cost of ownership and provide you with visibility, management, and control you need. I've picked two tools that we're gonna go through next after we lay down the foundation with Cost Explorer. So what is Cost Explorer? Cost Explorer has a comprehensive dashboard to view month-to-date costs, months and forecasted costs, and it allows you to save reports. It's quite user-friendly for all users from all levels. It also has an API available for custom applications to address specific cost management needs. In addition to that, it can identify basic anomalies, cost and usage events across your accounts based on historical patterns. One thing you might want to leverage is the recent announcement of having cost and usage reports available for member or linked accounts, meaning that member accounts in AWS organization can now set up cost and usage reports containing the specific cost and usage data for their own accounts without the need of giving them access to the pair account. This will help provide the portfolio teams with the visibility and traceability of their own usage and spend. The second tool is AWS Compute Optimizer, which uses machine learning modules trained on millions of workloads to help customers optimize their compute resources for cost and performance. You can take advantage of the recommendation Compute Optimizer to reduce your cost by up to 25%. Compute Optimizer delivers recommendation on compute services such as EC2, EBS volumes, and Lambda to help customers choose the right compute resources for a specific workload. As it analyzes resource configuration, utilization, and performance data of the workload to identify a dozen of characteristics. As an example, if the workload is CPU intensive or memory intensive, and whether it exhibits a daily pattern. The Compute Optimizer then uses machine learning to process these characteristics to predict how the workload would perform on various hardware platforms to be able to deliver resource recommendations. This will help you understand how your workload would perform on the recommended options before you actually implement these recommendations. So how does it work? Compute Optimizer uses predictive scaling machine learning algorithms to analyze the current configuration of your AWS compute resources and their utilization metric from Amazon CloudWatch over a period of the last 14 days. In addition to that, it leveraged data from billions of traffic patterns, machine learning modules trained on millions of workloads to help customers optimize their compute resources for cost and performance across all of the workloads they run. Compute Optimizer delivers up to 3 recommended options for each AWS resource analyzed to right size and improve workload performance. It can predict the expected CPU and memory utilization of your workload on various EC2 instance types. The pre-trained modules then process the last 14 days of load metric to forecast the load metric for the next 2 days. The module also performs regression analysis between load metric and scaling metric. It schedules scaling actions for the next 2 days and keep repeating the process every day. Compute Optimizer provides 2 types of recommendation. One is to lower the cost of your resources, as it can identify over-provisioned resources like EC2 instance, for example, and then recommend you to replace it with a more cost-effective instance type that will continue to meet your cost performance requirements. The other type of recommendation offered by Compute Optimizer are meant to improve the performance of your resources. For example, it might identify an EBS volume as not optimized if it's continuously reached its maximum IOPS. In this case, it might recommend a volume type that offers a greater IOPS or throughput to better match the performance requirement of the workload. All recommendation Compute Optimizer provides have the current price of your resources alongside the price of the generated recommendation, so you know exactly how much you're saving. It also displays metric utilization graphs for your resources in the last 14 days and the projected utilization data for the recommended resources. The best thing is Compute Optimizer is available for customers at no additional charge. The third is AWS Cost Anomaly Detection. It is another feature on the Cost Explorer that uses multi-layered machine learning modules, which learns your unique historic spend patterns to detect either one-time cost spike or gradual and continuous cost increases without you having to define or put any thresholds. It has a very simple three-step setup to evaluate spend anomalies for all AWS services individually, member accounts, cost allocation tags, or cost categories. A key feature of cost anomaly detection is that it will save time investigating spend anomalies by receiving automated root cause analysis, pinpointing potential cost drivers, such as usage type, could be data transfer cost, or specific AWS service, region, and member accounts. It will also keep you informed of spend anomalies through automated detection alerts, either via email or SMS topic, at the frequency of your choice. And similar to Compute Optimizer, cost anomaly detection comes at no cost for customers. And with that, let's check our key takeaways. The first takeaway is you gotta measure business outcomes and workload efficiency. Try to avoid building waste from the start. The second, you need to be aligned to AWS well-architected framework by running well-architected review and go through the well-architected labs to follow its best practices. The third takeaway is to optimize your workload by using tools and features available to you like AWS Compute Optimizer and anomaly detection. Finally, I would like to conclude by reminding you that helping our customers save money is part of our DNA. I hope this session has been informative and can help you get started on your cost optimization journey. Please complete the session survey, and thanks for watching.